Hey, welcome back boys and girls to lesson 24 of the Dead Earth game development series. Gary Simmons here for the Game Institute, and in this lesson we are going to create our zombie Jill's feeding state. Now the feeding state is going to be a pretty cool state for us to implement because it's going to allow us to add a new layer to our animator where this cinematic sequence is going to play out. Now if you look at our animator at the moment, we only have a single layer, the base layer. So we're going to create a new layer called the cinematic layer, and that layer is going to completely override any animations currently playing on the base layer when it's activated. And that's what we want, because when Jill detects that she's at the target and the target is a food source, she might be doing a crawling locomotion, she might be turning left or turning right in patrol, she might be walking, jogging or sprinting. And we don't want to make a load of transitions from all of those states to cover all of the different permutations, if you like, that she may go from an animation into the feeding state. So we're going to have this new layer called the cinematic layer that's specifically for invoking animations that must be carried out immediately and override any current animation that might be playing in a layer underneath it. So how is Jill's animator going to know when she's in the feeding state? Well, you will remember, if we look at the parameter list in Jill's animator, we have this feeding boolean that we added several lessons ago. And of course, our feeding state is going to take care of setting that boolean, which is going to activate animations on the cinematic layer. But before we do that, let's talk a little bit about what a food source is. A food source can be pretty much anything you like in Dead Earth. It could be dead bodies on the ground, which is what I use them for most of the time. But it could be anything. It could be a zombie rummaging through a trash can. It could be a zombie feasting on the remains of a dead animal. It could be a zombie wading through a pile of rubbish or a pile of dismembered limbs on the floor. It doesn't really matter what it is graphically. As far as our system is concerned, all a food source is a trigger that is on the AI visual aggravator layer that has been flagged with the tag AI food. So just to remind you, if I select any object in our hierarchy so that we can see the tag and the layer drop downs, it's going to be any trigger that we assign to the visual aggravator layer and tag with AI food. So whether we attach that trigger to the neck bone of a dead body or whether we assign it to a pile of rubbish on the ground doesn't matter. The zombie's not concerned. All it knows is when it gets to that trigger, it's going to go into the feeding state. And when it goes into the feeding state, it's going to replenish its satisfaction. So if I select Jill's AI entity game object in the hierarchy view so that we can see her zombie state machine component in her inspector, you can see and are reminded that many lessons ago when we created this class, we also added this satisfaction property, which is a measure of how hungry, or in this particular case, how unhungry Jill is. In other words, if satisfaction is 0, she is very hungry and very likely to deviate off of her patrol route to investigate a food source, even if that food source is at the very periphery of her sensor trigger. But if she's not that hungry at all, then she might only investigate that food source if it's very, very close to her. And hopefully you'll remember that when we were doing the threat assessment in the AI zombie state class, we only actually considered food as a visual threat if its distance was such that it fell within its satisfaction threshold. So at a satisfaction of 0, that basically means that the zombie would go right to the very far reaches of its sensor range to investigate a food source to try and replenish its satisfaction. But if it was at 0.5 hunger, for example, then the zombie would ignore any threats that were more than half the radius of its sensor range away. Now while Jill is in the feeding state, over time we're going to have that feeding state increment our satisfaction value so that if she stays there long enough, her satisfaction will go all the way back up to 1 or close to it. But of course, once she's fed, that basically means that it would go up to 1 and then she would never be hungry again. So what we also need to do is probably revisit our AI state machine base class and just put some code in its update function that says every frame, if the zombie is patrolling, we are going to deduct a little bit from that satisfaction value so that as she burns off the calories patrolling the level, that is going to be decremented. And what we'll also do is we'll also decrease it more based on the speed that she's going. So a zombie that's attacking or in pursuit mode would probably burn a lot more calories than one that's just stood in the idle pose. The nice thing about that, if we were just to create a duplicate of Zombie Jill now, and then just, say, go down to a patrol state and change her patrol speed from, say, I don't know, 2 to 1, or change her pursuit speed from 3 to 2, then what we would have is the exact same code react quite differently, because the first zombie that was patrolling more quickly would get hungry more quickly and would investigate any food sources that are much further away, whereas that exact same code on another zombie, just going at a different speed, would have its satisfaction depleted much less quickly, and therefore we would see that zombie quite possibly ignore many food threats that were on the periphery of her sensor trigger. Okay, so we basically know how this is going to work, so let's go to our animator now, and let's create that cinematic layer. A new layer in our animator. So I'm going to call up the animator window. If you've accidentally shut down the animator window, you can call it up by going to the window menu and choosing animator. Very important you choose animator, not animation. Okay, that's a different window entirely. So it's animator that you want. Okay, and what we're going to do is we're going to make sure we have the little layers tab selected, and we're going to click the plus sign, and I'm going to call this new layer cinematic. And because the cinematic layer is underneath the base layer, it basically means that it's going to have a higher priority, okay? So if we have any animations on this cinematic layer, it's going to override the animations of any bones that are also being animated by animation states on the base layer. And that's exactly what we want. We want this layer to be able to completely take over the animation of our zombie's bones to push it into the feeding state. Of course, in order for that to be true, we just need to make sure that we definitely have this cinematic layer with a weight of 1, so it means it 100% overrides the layers underneath it. At the moment it's got a weight of 0, so that means that any animations we played on this layer would do nothing. So let's slide that all the way up to 1. We don't want them to blend with animations on the base layer. Oh no, my friends, what we want is we want a full override of anything that's currently playing underneath it. So now we need to put our zombie feeding animations in this layer. Okay, so let's go down to our project view where we imported all of those animations what seems like an eternity ago. And I think we have these animations in our Mixamo animations pack. No, we don't. We have them in our animations/Game Institute/cinematic folder. And you can see what we have is 3 animations. We have the zombie eating intro, which is where the zombie goes from a standing pose down onto all fours. And we have the zombie eating animation that is going to sort of basically just loop around forever until she's got a full belly. So we want to blend from the intro pose into that pose, and then when her belly is full, we are going to transition from that animation into the zombie eating outro animation, where she's had enough and she stands back up, and then from there we'll blend into an alerted state. So what I'll do is I'll drag over the eating animation, I will drag over the eating intro animation, and I will drag over the eating outro animation. Okay, so if you're following along and you have these animations, that's what mine are called: zombie eating intro, and zombie eating outro. Now by default, when we put an animation clip into a new layer, Unity tries to be clever and will automatically make that the default animation state in that layer. And that's identified with the fact that it's orange and it's been connected to the entry node of that layer. Now that's not what we want in this particular layer, because the last thing we want is when this animator is first created, the zombie eating state starts playing by itself, because that will overwrite anything that is in the base layer underneath it, completely undoing all of that really clever animation stuff that we've built in the layer underneath it. Remember, the entry state on the base layer was used to tell the animator to start off in the idle state. In our cinematic layer, it's currently telling the animator to start off in the cinematic layer in the zombie eating state. We definitely don't want that. The zombie eating animation is going to have lots of keyframes for bones that are also being animated by our base layer and will completely override them. So what we need to do is make sure that these 3 animations are never ever activated unless we absolutely want them to be, and only at that very specific time. When we're not in the eating state, we don't want the cinematic layer to do anything at all. We want it to essentially sit idle. And we can do that very easily by just creating a completely empty animation state. Essentially a state that has no animation data whatsoever, so that there's no data that could possibly override the layers underneath it. If we just click in any of the empty space in the animator window and right click, that'll bring up the context menu, and we can choose create state and then choose empty. By default, this creates a new empty state and calls it new state. With the new state selected, if you look in its inspector, you can see it's called new state. I'm going to change that to empty state, because I think that's a little more descriptive, and you can see it's now been updated in the animator pane as well. But you can also see, if you look in the motion field, it currently has no animation attached to it, so we know there is going to be no data in this state that could possibly interfere with anything in the layers underneath it. So now all we need to do is make sure that the entry node is attached to this state and not our eating state, and that's easy. We just make our empty state the default state by right clicking on our empty state and choosing set as the layer default state. Now our empty state will be playing in the cinematic layer, but will have absolutely no bearing on anything underneath it. And in fact, we can see that this is true right now. If I go back to the scene view and press play, even though we have that empty state playing in the cinematic layer, it's going to do nothing to our base layer. It's essentially an empty state. So let's go back to the scene view and just double check that we're not overwriting any of that beautiful work we've done over all the weeks that have gone before us. And as you can see, she is correctly in idle, then she's going to go into patrol, and everything is intact, and thank goodness for that. So what we need to do now is create some transitions from our default empty state into our zombie eating intro state, because remember, these three animations have to be executed in sequence to get the effect that we want. We have to see the zombie go from a standing to a kneel, then we need to see the zombie transition into that looping eating while kneeling animation, and then stay in that animation until his satisfaction has reached a suitable amount, and then we will transition into the zombie eating outro state. And also we need to make sure that the intro and the outro states also play out to their entirety. We don't want them being transitioned out of too soon, because otherwise it would break the way that these three clips are supposed to fit together. So we have to have the eating intro play out to its entirety, so the zombie goes from a stand down to a kneel. Then once it's in the kneeling pose at the end of its timeline, we then transition into the eating state. And then when in the eating state, it doesn't really matter, we just stay there looping until we're full up, and then we can then transition into the outro state. And the outro state, like the intro state, also has to be played out to its entirety to make sure that the zombie has got back up from its knees, back onto its 2 feet, before transitioning back into our empty state again. And of course, at that point, when we transition back into the empty state, the base layer, whatever state we're in down there, will take over, and we'll be in control of posing our character. So there's obviously one condition which we know must be true in order to transition to the first of our 3 animation clips, and that is if feeding is true. In other words, if our feeding boolean has been set to true. But you're going to see a little bit later on that there's also going to be another type of locomotion that we haven't added to our base layer yet. At the moment, on our base layer, all we have is walk, jog and sprint, and turn right and turn left. But we're also going to have a little subsection of locomotion to deal with zombies that are crawling, that no longer have the use of their legs. Perhaps because that's how they started off at the beginning of the level, or perhaps because the player has damaged their legs to such an extent that the zombie can no longer get back up, so it will start crawling towards the player. Now, when the zombie is in the crawling state, that whole little subsection of animations is going to be triggered by setting the crawling boolean to true. So when the crawling boolean is true, our animator will know that these are the animations that will be played, and we're going to add those to our base layer a little bit later on. But the reason I mention them now is because on our cinematic layer, we also don't want to transition into this eating animation subsection here if we're not stood upright. So if we are a crawling zombie, then we will implement something else down here a little bit different to deal with crawling zombies that are feeding. But we'll add the whole crawling stuff to these layers later. So for now, all we need to know is we only want to transition to the first of our 3 states if feeding is set to true and crawling is set to false. So I'm going to right click on our empty state, choose to make a new transition to hook it up to our zombie eating intro state. Then I'm going to add some conditions to that. The condition I'm going to add is if feeding is set to true, and then I'm going to add another condition saying if crawling is set to false. Now obviously we've implemented no code yet that even bothers with setting the crawling state. We'll deal with that later. We also want to untick has exit time. Our empty state has no exit time, so it's not really an issue anyway. But most of the time we don't want to use exit times, except for example in the case of our zombie eating intro animation, because we do want that animation to play out to its entirety. So we'll create a transition now from our eating intro state to our zombie eating state, and we will set that transition simply to feeding equals true, but we will leave has exit time set So just imagine how this is going to happen. Feeding is set to true in our parameter list. Empty state is transitioned into the zombie eating state. Now feeding is also true at this point, but it won't transition into our zombie eating state yet because the exit time has not been reached. So the zombie eating intro will play out to its entirety and then we'll start blending into our zombie eating animation. So let's now create a new transition from that to our zombie eating outro. And of course the transition is simply going to be when feeding no longer equals true. In other words, when feeding equals false. We don't have to wait for any specific point along the eating animations timeline to transition out to the eating outro, so we can untick the has exit time for the transition from zombie eating to zombie eating outro. Finally, we want to create a transition from our zombie eating outro back to our empty state. So once again, the base layer can take over posing of our character. And this transition is going to be very simple. It's simply going to be has exit time. In other words, once we have a full belly and we transition into our outro animation, we just want that to play and then unconditionally go back to our empty state to let the base layer take over. So just to recap, we go from empty state to intro. If feeding is true, crawling is false. No has exit time. We then go from our intro state to our feeding state if has exit time is reached and feeding is true. In fact, to be honest, we don't even need that condition. I'm going to delete that condition because once we get into the zombie eating intro, we don't want to be stuck in a situation where feeding might be set back to false and we've got like no way out of this animation. So we actually don't want that at all, do we? So let me select that feeding equals true. Delete it. So once the intro animation starts, we definitely want it to play out and we definitely want it to transition into our zombie eating animation. So the only condition there is that the exit time is reached. Sorry about that. Bit of a mistake there. And in our zombie eating animation, which will just keep on looping round and round until our zombie Jill has a full belly, we will only transition out of that when feeding is set to false. And we have no exit time there. We don't have to worry until that animation reaches the end of its timeline. It should blend fine into our zombie eating outro. Finally, our zombie eating outro animation should just play out to its entirety and then go back to our empty state to allow the base layer to take over control of our skeleton. So we will set the transition from outro to empty state to simply be has exit time. The nice thing about the animator window is that if we were to press play now and making sure that we had the game object selected that has the animator on it, which of course is OmniZombieJill's AI entity child object, then we would ordinarily not only be able to see the animations playing out on the various different layers, like for example if I press play now, you can see that on the cinematic layer we have the empty state that it's just playing, and on the base layer it's telling us it's currently in the idle state. But if we call up the parameter list, we would ordinarily be able to just flick that feeding boolean and we should be able to activate the feeding subsection on our cinematic layer. But you can see we can't do that. When I try to click it, it won't let me set it to true. And of course the reason for that is that our AI zombie state machine is trying to be very clever behind the scenes, and we want it to be, but it's actually stopping us do this test at the moment. And that's because in our zombie state machine's update function, it's making sure that all of these properties are set to what they're currently set at in the actual state machine. So because we haven't made a function call to set the actual feeding property in our state machine to true, the state machine thinks that feeding is false, and every frame it's setting feeding back to false. So even if we click it on like that, it immediately turns it off again at the next frame. So to test this just very quickly, we'll jump into our AI zombie state machine class and we'll just comment out the line that keeps setting this feeding property to false, at least until we've created the feeding state that will set that property in the state machine properly. So let's go down into our scripts folder, our AI folder, and open up, I think it's in AI zombie state machine. So here we are in the state machine class. There is our private feeding boolean. And of course we should also have a feeding property. Yep, there it is there. And of course that's the property that our child state, when we create it, our feeding state, is going to use to set the feeding boolean, the feeding state if you like, inside our zombie state machine to true. But because we haven't done that yet, you can see that in our state machine's update function, it's just always setting the feeding parameter to false. So for now, let's just comment that out so that we can change it on the fly in our animator window. And fingers crossed, that should allow us to see what our feeding animation is going to look like. So I'll wait till she starts running. You'll also be able to see what's happening as well in the animator window. You'll be able to see the transitions happening. So there she goes, she stops and she goes down. Okay, it kind of looks a bit weird because we're seeing it from that top mounted camera. So what I'll do, I'll move the animator down to the bottom area of Unity so that we can watch it in the scene view, so that it looks a little bit more like what the player will see. Of course, we can set that at any time, and whatever state it's in, it will override it. So wait till she starts running. And there you go, she goes down. She finds a body, she goes down. And if you think it's a little bit abrupt, you can always lengthen the duration of the transition into the zombie eating intro. Let's make it a little bit longer, like so. See what that looks like. Oh, let me call up the animator window again. Select the feeding parameter. Yeah, that looks better, doesn't it? Doesn't that look better? And then I untick it and she stands up again. Then I tick it again and she goes down again. And she'll just stay there feeding forever. Actually, I better just check I've got the eating animation looping. Yes, I have. And then when she's got a full belly, our feeding state, our script, will simply just set that back to false again. And then it will stand up and resume its patrol. And the great thing about this is it'll also look really good. Imagine a zombie's feeding, okay, which remember is the lowest priority threat, and then we walk up behind it with a flashlight. And when our player is behind it, remember the flashlight is going to be implemented as a kind of trigger that's sticking out in front of the player. And when Zombie Jill enters our flashlight trigger, that trigger will register ourselves as a visual light threat, which is a higher priority threat than visual food, and that will transition us out of the feeding state, which will untick the feeding boolean, like so, and then she'll stand up and she'll go into the alerted state, and then she'll pan around trying to find us. But as you can see, pretty easy what we're going to do here. Ba-bam. Good, isn't it? Okay, so our animator is already set up and ready to go. All we need to do now is write the script that transitions into the feeding state, sets that feeding boolean to true, and just kind of make sure that when the zombie goes down into the feeding state, that we kind of rotate it so that its head is roughly in the direction of where the actual food source is going to be, which might be a trigger placed on the neck, for example, of a dead body. So what we'll do is we'll go into our project view. Once again, in our AI scripts folder, I'm going to create a new C# script. I'm going to call this, you probably know by now what I'm going to call this, AI zombie state feeding. Actually, I'm going to call it feeding 1, although I'm pretty sure we're not really ever going to create different types of feeding states because there's not really much a feeding state has to do. So probably the same feeding state will fit all of our different hostile characters. Okay, so I'm now going to open this up in MonoDevelop. I am of course going to delete the boilerplate code, and I'm going to change the base class from MonoBehavior to AI zombie state. Okay, and here we are. We're ready to start writing our feeding state. So let's think about the variables that we're going to need to expose in the inspector so that we as developers can configure our feeding state. For the moment, we just need one. We just need the ability to set a slurp speed like we do in other states, because you might think it's a bit weird to have a slurp speed when the zombie is on all fours, but when our zombie approaches its target, it's going to enter its target trigger and it's going to immediately activate that animation that has it falling onto all fours. But of course, when it enters the target trigger, it may not be facing exactly the direction that the actual food trigger is at. So we just want to make sure that when it's in this state that we just keep rotating it around so that the head is always facing in the direction that our little food trigger is at. Now you might be thinking, well, aren't we going to see a little bit of spinning when it first goes down? Most of the time you won't, and even if you do, it's going to be barely noticeable. So it's something that I'm quite happy to live with to keep the zombie aligned with its food target. So I'm going to create a private float called slurp speed, and I'm going to serialize the field so it shows up in the inspector. So now let's sort out some of the internal variables that we're going to need. And this is interesting because I think we're going to do something with the animator in this lesson that we haven't done in any other lesson. You see, if I go back to the editor for just a moment so that we can see our cinematic layer in the animator window, we can see that our eating animation is actually made up of 3 separate animation clips. One when we're going down, and one when we're coming out. But of course, we're going to be in the feeding state even when we're going down, because it's the feeding boolean, if you like, is the thing that triggers that animation clip. So we need a way to recognize when we are actually in this middle state. We are in the process of feeding, because only when this middle animation is running should we really be replenishing the zombie's satisfaction value. And later in this lesson, we're also going to add a little blood particle system to the scene that is going to be mounted in front of the zombie's face, so that when it's feeding, it can kind of squirt some blood up past the zombie's head and look like it's blood that's squirting out of the body as the zombie rips in to its flesh. And likewise, we don't want that particle system happening unless we're in this zombie eating state. Because when we're in the zombie eating intro state, if we simply start replenishing the satisfaction then and squirting blood out of our blood particle system, well, the zombie might be at the very beginning of this animation and may not even be on all fours yet. Look completely silly, wouldn't it? So we are going to go back, and we are going to create some variables that are going to allow us to not only retrieve the state zombie eating, so that we can ask the animator, is this the state that is currently playing? But we're also going to need, in order to do that, to also get the index of this cinematic layer. Now, you might look at it at the moment and say, well, hey, Gary, we know the index of the cinematic layer, because if we imagine the base layer was layer 0, we know that the cinematic layer is layer 1. But I definitely don't want to hard code layer 1 into this state, because we're going to actually add quite a few more layers to this animator before we're done. So cinematic layer is going to end up probably being something like layer 6 or 7. So we don't want our code dependent on that and completely breaking when we decide to add something as simple as a new layer. So in order to check whether the zombie eating state is playing, what we first need to do is we need to figure out what layer it's on. Well, we know that, the cinematic layer, but we need to get the index of that layer. And the animator class has a function that allows us to do that, called getLayerIndex, where we can pass in the name of the layer, cinematic, and it will return that index to us. So we're going to want to keep track of that, an integer, which will store the layer index of the cinematic layer. And we're also going to need to inquire about the zombie eating state using the animator's getAnimatorStateInfo, but we don't want to pass in the actual name of the state here, because we know that those string comparisons can be pretty costly. So what we'll do instead, just like we did in our state machine, is we'll generate a hash of the name of this state, and then we'll use the hash version of the function. However, I'm not particularly happy leaving the name of the state then at zombie_eating, because we want our feeding state to be able to work with all sorts of animators. It might not be a zombie, it might be an animal, might be a duck. What do ducks eat? I don't know, bread, I suppose. But we wouldn't want a duck eating bread having to check if a zombie_eating state in its animator was playing. So I think what we'll do is, in any animator that we create for any creature or NPC, whenever there is a state that is specifically designed to replenish the character, in other words, when it's feeding, we will actually call that state feeding state, okay? And then it will be the same across all of our different animators, and our feeding state will work with them all the same. So I'm going to change the name of that by left-clicking on our zombie eating state, and I'm going to call it feeding state, like so. Let's save that off. Then I'm going to go back to our script, and I'm going to generate a hash for that string, feeding state, using, remember, the animator string to hash function. So that will return the hash, which I'm going to store in this private int called _eating state hash. We're also going to need an integer to store the layer of the cinematic layer when we fetch it from the animator. So I'll just set that to -1 by default, and I'll call that eating layer index. I think that's all the variables we need for now. So I think the next thing we'll do is we'll generate the first function that we seem to override in all of our states, which is the getStateType function, which allows this state to return back to the zombie state machine the type of state it is. And of course, this is the feeding state. So it's a public function. We override it from the base class, and it returns AI state type. It's called getStateType with no parameters, and of course this time we return AI state type.feeding. Oh yes. Okay, so now let's override the onEnterState function. And in our onEnterState function, we'll do what we've done in all the other classes. We'll have a debug log saying entering the feeding state. We will of course call the base class, let the base class implementation have a chance to do what it needs to do, which is hopefully also setting up that zombie state machine. And if after calling the base class zombie state machine is null, then we got to return. There's nothing we can do. So the next thing we want to do is talk to the animator, and we want to ask it for the integer index of a layer called cinematic. And I do this in the onEnterState function because we know that the animator will be fully created at that point. And I only do it if layer index is -1. There's no point doing this every single time we drop into the onEnterState function, because we may go in and out of the feeding state several times throughout the level. And it's a cost that we don't need. So we only ever need to do this the very first time, which is why I say if eating layer index equals -1, then it means this must be our first time we haven't fetched it yet. So what we would say is eating layer index equals, we will access our state machine, we will get its animator property, and we want to use a function called getLayerIndex, like so. And the getLayerIndex function takes a string, and that string is the name of the layer, which in our case, of course, is called cinematic. Of course, it goes without saying that the spelling and the capitalization needs to match exactly, or you will be in big trouble, my friends, and nothing will work. Okay, so we now have the integer index of our cinematic layer, and we're going to use that later on in our onUpdate function to check that layer, and in particular, the feeding state, to see if that's the current state. And if it is, then we know that we are right bang smack in the middle of eating, and we can add some percentage points to the zombie satisfaction. And later on, when we implement the particle system, we can also emit some particles from that as well. Okay, so next we'll set the properties of our state machine for this state. Of course, we set seeking to 0, we set speed to 0, we're not running and eating at the same time, and we set attack type to 0. Of course, the difference here is we set feeding to true, which we've never done in any of our other states. And we know that when we set feeding to true, folks, on this cinematic layer, this transition is going to be activated, and our zombie is going to stop in its tracks, and it is going to drop to its knees. And we've seen that already working. But if you remember, we had to hack it, didn't we, in the state machine, which reminds me, I must remember to uncomment out that line is it in our zombie state machine? Yes, it is. Remember, I commented out that line that actually set the state of our feeding boolean into the animator. Because I'm telling you folks, that right there, where I temporarily comment something out to test something, and then forget I've done it, that right there is the thing that chews up more of my debug time than anything else. Okay, so remember guys, that was in our AI zombie state machines update function. So let's go back to our feeding state and resume. So just like with our other states, we just want to tell the nav agent that it's going to be in control of updating the position of our transform, but it will not be rotating us. So that is our onEnterState function complete. Let's now kick into the onUpdate function. Actually, no, we won't do that. What we'll do first of all is we'll implement a function that we haven't implemented in any of our other states, I don't believe, which is the onExitState function. Because what our onEnterState function is going to do, obviously, is set feeding to true. And then in our onUpdate function, if it finds that its belly is full, or if another threat comes along, which is much more important to the zombie than food, then that zombie is probably going to drop into, say, the alerted state. And when it does that, it will return AI state type.alerted, and we know that our state machine, when it gets back a different state type to the one it's currently in, is going to transition into that new state. But before it does that, it's going to call the current states, in other words, our feeding states, onExitState function. And we can use that then to set the feeding boolean back to false, like so. Oh yes. So as you'll probably remember, this needs to be a public override. It returns nothing, it takes no parameters, it's called onExitState, and we simply just set feeding to false in this case, and we know that in our animator that is then going to trigger this transition here that is going to take our little Jill here out of the eating state, let her first of all play her standing up animation, and then it will transition back to the empty state where our base layer will then resume control of Jill's bone hierarchy. Okay, so let's now work on our onUpdate function, which is going to be moved through pretty quickly now because it's mostly a rinse and repeat of stuff we've done before. In fact, it's going to be more simple than most of our other states. So there's nothing here that's going to be new to you. So just to remind you, our onUpdate function returns an AI state type, and it's a public override, and by default whenever we create this function, one of the first things we always do is just put that little return statement at the bottom so that it returns the current state that this update function belongs to. That's our way of saying if nothing has happened in this update function that has caused us to transition to a different state, then just stay in the same state. Okay, so the first thing we're going to do in this function is we're going to have a timeout, much like we do in the alerted function and the pursuit function, where we basically check if we've been in our feeding state long enough such that we should just resume our patrolling of our waypoint network. But we're not going to be using a time for this. We're going to be using our zombie state machine's satisfaction factor, because remember, while we're in this onUpdate function, our satisfaction will be going up and up and up. And once it goes past the point where we consider, we have a full belly, which I think I'm going to use something like 0.9, about 90%, but you can use whatever you want. So when Zombie Jill's belly is 90% full, then all we really want to do at this point is say we've been here long enough, let's now grab the next waypoint, set it as a target, and then drop back to the alerted state, so that the alerted state can, if the waypoint is behind the zombie, it can seek our zombie left and right. But if we get to the alert state and the waypoint is in front of our zombie, well then the alerted state will immediately go into the patrol state, so we don't have to worry about dropping back to the alerted state for a frame or two. So to do that, we will say if zombie state machine.satisfaction is larger than 0.9, then we'll just use that get waypoint position function that we wrote at the end of the last lesson. Now remember, this is often used for fetching the 3D position of the waypoint that the state machine is currently heading towards on its waypoint network. But we're not really interested in the 3D position here, so we don't bother assigning the return value to anything. We're just using this function because we know that it also sets the waypoint as the next target. And of course we pass false so that we don't increment onto the next waypoint in the waypoint network. If our zombie was heading towards waypoint 3, for example, and whilst en route to waypoint 3 it saw a food source and diverted off of its patrol path to go and feast on that food, then once its belly was full, it should really resume its patrol path and carry on towards that same original waypoint, waypoint 3. So that's why we pass false. So of course we have our waypoint now set as the current target. So if we drop back to the alerted state now, the alerted state will have that position set as the target that it's trying to seek to, or if that position is already in front of the zombie, then the alerted state is going to push us straight through to the patrol state. So we simply return AI state type.alerted. So next we need to do the same threat assessment that we do in other states. We need to examine the visual and audio threats and see if there is anything that is more important to our zombie than its current threat or its current target, which is the food source. Now that's pretty easy, right? Because we know that unless the other threat is food, or there is no other threat, then there is pretty much no other threat that is less important than food. So if we have a visual threat that isn't food, then we definitely want that to be our new target, and we want to come straight out of the feeding state and back into the alerted state. So we'll do pretty much the same as what we just did. We'll say if the zombie state machine's visual threat type is not none and it's not food, so in other words it's either the player, a visual light, then we want to set this visual threat as the new target and then return AI state type alerted, so that when we enter the alerted state, our zombie will either seek left or right to try and acquire that target within its view cone, or if it's already within the view cone, it will push straight through into the pursuit state and start sprinting towards the source of that threat. So of course we need to do the same for an audio threat as well. If there's any audio threat, then it's more important than our current food target, so we should do exactly the same thing. We should say if the zombie state machine's audio threat type equals AI target type audio, hey, set this as the new target and return AI state type.alerted. So next we're going to implement the conditional that will see us incrementing our zombie state machine's satisfaction factor if we are in the feeding state. So what we want to do is contact our animator and inquire about whether we are currently within this state in the cinematic layer, and if it is, then we want to slowly move up our zombie state machine's satisfaction. However, I think we should probably make the speed at which a zombie replenishes a property of the parent state machine. And in fact we also said that as the zombie runs around the level, we're also going to add some code that depletes its energy levels or makes it more hungry. So I think we should probably, in our zombie state machine class, add two more variables that allow us to set the replenishment rate and the depletion rate of the zombie's energy. So I'm going to do that before we go any further. So I'm going to call up my AI zombie state machine. There you go. And I'm going to add a new serialized field of type float, and I'm going to call that replenish rate. And I'm going to set that to 0.5. Now we're going to multiply this by time.delta time. So it basically means at 0.5 we're going to replenish 1% every 2 seconds, or 0.5% every second. So next up, we'll also add a depletion rate, because we often want the depletion rate to be less than the replenishment rate. Because I don't know about you, but I don't have to split my day into 2 halves. I don't have to spend 12 hours eating just so that I can spend 12 hours awake. No, I can get away with just 10 hours of eating, and that keeps me awake for 14 hours. So what we'll do is we'll create another private variable of type float, and we'll serialize this as well, so it's something we can set in the inspector. And I'll call this depletion rate, and I will set it to 0.1 by default. So this basically means that our satisfaction will deplete 1% every 10 seconds, or 0.1% every 1 second, depending on how you want to look at it. So we don't really need to have a property for the depletion rate, because this is all going to be handled in the update code of our zombie state machine, and we'll do that a little bit later on. For now, we just need a property that allows our feeding state to read what the replenishment rate is, so that it can add that to our zombie's satisfaction. So scrolling down to my public properties block, as you can see, I have a public float property called replenish rate without the underscore, which simply has a getter that returns our replenish rate private variable. So if I save that off now and go back to our feeding script now, the next thing we want to do is we want to check if our cinematic layer is currently playing our feeding state animation, and if it is, then we want to start incrementing the satisfaction factor. We want our zombie to replenish. So in order to do that, we're going to use a function of the animator called getAnimatorStateInfo. And if we look at that in the Unity documentation, you can see that it contains quite a lot of information about the animation, whether it's set to loop, what the length of it is, what the normalized time is within that animation. But the thing that we're really interested in is the short name hash. This will basically be what the name of the actual state is. So in our particular case, feeding state. Of course, it will be the string feeding state hashed. So we have to compare it against the feeding state string already hashed, which we've already done, right? Because at the top of our function, we had that eating state hash variable that we set using the animator string to hash function and passing our feeding state string. So we already have the hash of that state, so we can already compare it directly against the value that is returned there. You'll notice there's full path hash and there's short name hash. Short name hash is literally just the name of the state, but if you do the full path hash, that will also include, if I call up the editor, the layer that it's on as well. So it might be, for example, cinematic feeding state, and that path might drill down even deeper if it was inside a sub-state machine on the cinematic layer. But we just care about the feeding state because we're going to tell that function that we're only checking the cinematic layer. And we do that by doing the following. So we get our state machine and we get access to its animator, and then we use its getCurrentAnimatorStateInfo function, which remember is going to return one of these structures here, an animatorStateInfo. And like I said, we have this short name hash property, which if it is our feeding state that is active, but then that hash should match the feeding state string that we hashed earlier on. So we can pass in the layer, and this is really important. We need to pass in the layer that we're inquiring about, because there isn't just one animator state that is necessarily running. For example, we know that we have a base layer that might, for example, still have the idle animation running, and the cinematic layer that might have the empty state running, or the zombie eating intro state running. So we also need to say we're interested in finding out what the current state running on this particular layer is. And because the get current animator state info function takes a layer as an integer, not as a string, that is why we used the get layer index function earlier on to grab what the integer index was of our cinematic layer. So we can now pass that value that we cached straight in there, like so, and then we can access its short name hash. So we're basically saying if the zombie state machine animators, and we call its get current animator state info function to get back the short name hash of the currently active animation state on our cinematic layer, well, if the name that is returned is the same as the hash that we made earlier on, well, then we know feeding state is active. So we're going to drop into this conditional, and we're going to add some value to our zombie state machine's satisfaction factor. So what we'll do is we will say zombie state machine.satisfaction equals, now I want to add a value to it, but I want to make sure it never exceeds 1, okay, because we could be in the feeding state for many minutes, and we might get up to a full belly in just the first couple of seconds of that minute. So we want to make sure that it never surpasses 1. So we're going to do a mathfmin to make sure that we use the minimum of 1, or the new value that we're just about to create, which is going to be satisfaction incremented. So as the first parameter to our min function, we will pass in our satisfaction factor. Added on to that will be time.delta time multiplied by our zombie state machine's replenish rate, which was that new property we just created. But like I said, this could possibly take our satisfaction rate outside the 0 to 1 range. So we're just going to make sure that we take the minimum of that value and 1, so that if satisfaction was to go to 1.1, well then satisfaction would be set to 1 instead. Okay, so that takes care of replenishing our zombie satisfaction while he or she is in the eating state. So the final thing we have to do in this function is we just have to make sure, much like we did in our patrol state and our pursuit state, that our zombie remains facing its target. And if it's not facing its target, we're just going to rotate it so that it is facing its target. But we're going to do it nice and slow so it doesn't look too sudden. And that's what we're going to use that slurp speed for. Like I said, this is literally just a copy and paste from our other states. So there we have it. So assuming that we're not using root rotation, which we're not, because none of the zombie eating animations have root rotation, or certainly the root rotation that we'd be interested in, because we wish it to rotate round so it's facing the threat. We're going to get the position of our target, which remember is our food source in target pos, and just so that we calculate the quaternion as more of a 2D rotation, we're just going to set the Y of our target position to the Y of our current zombie's state machine, and then we generate a quaternion just like we've done before, just by taking our target position and subtracting from it our zombie's position. That will create a new rotation that orients our zombie facing directly towards the target. But rather than just set that immediately as the rotation of our zombie's transform, we'll do a quaternion slurp from our current rotation to this new rotation over time multiplied by our slurp speed. And that, my friends, is, for the time being at least, our feeding state complete. So if I go back to the editor now, what I want to do is create a mock food source, much like I created those mock sound sources. So I think I'll create one over here by this little manhole cover, so that when Zombie Jill runs around this corner, what she normally does is she normally goes into this room here to her first waypoint. But what she'll do instead is, as she comes around the corner, there'll be a bit of food, which in our case will just be a trigger, that will make her deviate off a patrol route, and instead of going in that room, she'll sprint towards this position here and hopefully go down and have a feast. Now, there's an awful lot that we've done before we've tested this, so if I've made some mistakes anywhere, I don't expect this to run flawlessly. So I'm going to go to the game object menu and I'm going to create a new 3D object of type sphere. What I like to do here is press Control and Shift. See, so it goes, the actual center of the transform goes square, and then when I move it around, because it was well underneath the level at the time, it allows me to kind of click it to the ground, stick it to the ground, so I can see what I'm dealing with. So of course, in order to make this a food source, what I need to do is set the layer of this object to visual aggravator and set the tag of this object to AI food. I also probably want to make this a trigger too. So I'm going to press play now, and fingers crossed this will work. So we'll see her run around, she'll see the food source, then hopefully she will sprint towards the food source, and all of this won't have been a big waste of time for us. So will she go in the room? No, she's seen it, and here she comes. And why is she not eating? Oh, well, I knew it was too good to be true. She's given up eating now. In fact, if I go to the console window, she didn't ever drop into the feeding state. I think I know what this is. I have forgotten to actually put our feeding script on our zombie. How many times have I said to you that I need to do that as soon as I create the script, or otherwise I will forget and do exactly this. So where is our feeding state? There it is there. Oops. So I think what I'll do is I'll click the add component button. It's just getting a bit tight for room down there. And I will just type AI and then I'll add feeding that way. And there it is. It's pretty simple state in the inspector. Look, it just has a single parameter, which is that slurp speed, which I'll leave at 5. So hopefully now that will work. Please, please, please let this work. Come on, Joe. You know you want a snack. And if I select Zombie Jill's AI entity, go on, go down. Oh, there she is. She's eating. Let's select our AI entity now. Oh, did she filled up very quickly, didn't she? She filled up too quickly. I've obviously got her replenishment rate set way too high. Oh, I know what I've done. Of course, when we set the replenishment rate and the depletion rate, we said that these values represent the number of percentage points that are added onto the satisfaction per second. So in the case of our replenishment rate, we're saying that it's going to add on 0.5% every 1 second, or 1% every 2 seconds. And if we go back to my feeding code, it kind of looks like I'm doing that, right? The percentage points that we replenish per second multiplied by how many seconds have passed. But we must remember, of course, that our satisfaction value is not a value that represents a range of numbers from 0 to 100. It's from 0 to 1. 1/100th that amount. So if we want to find 1%, we don't want it to be 1, we want it to be 1/100th of 1. That's 1% of 1, right? So what we need to do is divide that calculation, which is assuming that the satisfaction rate is working in a range of 0 to 100, by 100. Like so. And if I save that off now, go back to the editor, and what I'm going to do is I'm just going to turn off the mesh render on the sphere, because I don't want to see the sphere. I just want to see the zombie eating it. And if I select Jill's AI entity, look at her satisfaction factor, it's currently on 0. We should see it replenishing a heck of a lot slower now. Come on, Jill, do your thing. Here she comes. She's at the food source, she's gone down to eat. And if we select her AI entity, there you go. Can you see her satisfaction moving up very slowly? Perhaps even too slowly. Maybe we want to set the replenishment rate to 1. But I'll leave it there for now, because we want some of our zombies to be in a state of feasting when the player is walking around the level. And if they all fill up too quickly, then there's a good chance if the player just runs through a crowded corridor, that none of the zombies would actually be eating. So what we need to do, I don't know if I can do it here. Yes, I can. So I'm going to move up the satisfaction factor up to nearly 9. And when it gets to over 0.9, she should come out of the feeding state. Oh, look at that. And then she should resume her patrol. She goes into alert. She resumes her patrol and off she goes. And she shouldn't come back to this food source next time, because we're not adding any code yet, which is diminishing. Yeah, as you can see, she's gone off. She's gone somewhere completely differently this time. It's quite weird that she's gone to the next waypoint, which we always see her do. But normally when she comes out of that room, she comes around here. But it's almost like because she entered it from the other side, the nav agent took her around the other side, which I find somewhat strange. But hey, pretty cool, right? It means it's a game that I'm writing, and even I don't know what the zombies are going to do. So I think, given the time, we're going to have to spread this feeding state over the next lesson as well. And then the next lesson will be pretty light stuff. It will be adding the particle system. It will be adding the depletion to our zombie state machine, so that as she runs around the level, her energy levels decrease based on the speed that she's going. And we're also going to visit some of the other states and just make sure that we tidy up 1 or 2 things that I know from testing since the last lesson are still acting a little bit weird in a few places. So we'll use the next lesson to do all of that cleanup, and then I think after that we will deviate away for 1 lesson and we'll get a rough player controller in the scene. And then when we've got that player controller working, we will carry on creating the attack state, which is the state that's going to see that zombie run up to us and attack us and do damage. There's still quite a lot to do on this zombie, believe it or not. I mean, we're going to implement body damage, where the zombie is going to be able to take hits from us and not necessarily just fall down, but stumble back left or right, depending on where she's hit. We're going to need to be able to ragdoll her, so that if she takes a blow to the head, even if she's not dead, we want to see her just slump to the ground like a ragdoll. And of course, we're also going to implement a system where the zombie, once it's ragdolled, can actually get back up again and come at you again if you haven't completely depleted its health. So, there's a lot of stuff still left to do on just our zombie alone before we get into the other stuff. It's pretty scary stuff, right? I mean, when you're videoing this stuff, you can't believe how long it takes. But I hope you're enjoying it. And the thing is with these sort of systems is they're things that you'll be able to keep and use, in all of your other projects. So it's like once you've written an AI system, it makes a really good foundation for all the other games that you're going to create. And I'm probably going to use an AI system based on this design for many of my projects to come. So thanks a lot, guys. I'll see you in the next lesson.